Good morning, students. Today we are going to discuss about fourth unit, which is the topic of ferromagnetic, dielectric and superconducting materials. Let us see first ferromagnetic. Usually we know that magnetic property means it has attracting the ferrous materials, and it has two poles, which is north and south pole. The same poles are repulse each other and the opposite poles are attracting each other. These are the basic property of a magnetic, as all we know. Now we are going to consider about a small specimen which is made up of iron. Take a small domain. Domain means which is a extremely small region. Consider this domain. Of a iron specimen. In this, the atoms are having in its own direction of movements of ions. Now we are supplying the external magnetic field, which is a small amount, that is weaker signal. External magnetic field. So what will happen because of supplying this external magnetic field inside this domain region? Here you see these atoms are moving in this way, but it will not get disturbance because we are supplying this external magnetic field very lesser amount, that is weaker one. So now we start to increasing this electric magnetic field furthermore, that means strong magnetic field. Now what will cause in this domain? Now the direction of this each atoms slightly changes its directions. That means you see it is rotating, slightly make the rotation comparing with this first one. Because of now we are increasing the magnetic field, it becomes as a stronger one. So if we still increasing this magnetic field furthermore, at finally what will happen means all the atoms are attracted by this electric magnetic field, so that all will starts to move in this direction, which is parallel to the external magnetic field. This property is known as a ferromagnetism of the material. Okay, now we just draw a graph between electric magnetic field, that is usually denoted by X axis H and Y axis M. M means magnetism of the specimen and H means electromagnetic field. Here you see, if we increase the external magnetic field, according to that the magnetism property of the material also increasing. So the curve goes in this way. So here the magnetic field increasing, according to that the magnetism also increasing in the specimen. At a certain stage, if you are still increasing the magnetic field, but there is no change in the magnetism of the material. That means there is no further increase in this magnetism. Once it reaches its maximum level, it becomes a saturated. So if we give the increasing in electric magnetic field, there is no change in this magnetism. So what will happen means, now we start to reduce this magnetism by means of reducing the electric magnetic field, external magnetic field. So that what will happen means, the electric magnetic field is reducing, so that the magnetism of the material also reducing gradually. So at this line, that means in the x-axis, you see the magnetism becomes 0. So still we are further decreasing this magnetic field. It reaches the 0 or below 0 or negativity magnetic field. This is positive side, this is negative side. So it reaches the maximum level here. Then what will happen means, again we start to increasing the magnetic field. So now the magnetism property also increasing from negativity to this 0, then 0 to its maximum level. So this forms as a loop, which is called as a hysteresis. Loop. Okay, first we take this point. We see that if we are increasing the magnetic field, the magnetism property also increasing. Here it reaches the saturation limit. Then if we start to reduce the magnetic field, it again reducing the magnetism. In this point, the magnetism becomes 0. So this point is known as coercivity. Coercivity, that means the amount of magnetic field needs to be applied to become the magnetism of the property of the material to 0 position. So that means there is no magnetism in the material. That means 0 magnetism. To bring the material to the 0 magnetism, how much amount of the electric field, magnetic field is applied, needs to be applied. That is called as the coercivity. Okay. Then here you see in this magnetic field, it is the starting point or 0. But in the, you see this in the vertical line, here some magnetism property is there. Still it is there. So when the magnetic field is 0, even the magnetic field is 0, but the material possesses some magnetism in it. That property is known as remnant. Remnants or retentivity. So here we have to consider these 2 points. So the magnetic field is 0, but it having, every material having its some magnetism property in it. That is called as the retentivity. But if we bring the electric magnetic field to 0, how much amount of electric magnetic fields need to be applied to bring the magnetism property of the material is 0. That is called as the coercivity. So ferromagnetism is the property of the material or specimen which is having ferric alloys. Thank you.